In this tutorial, we're going to take a look at making assemblies using Assembly 4. The Assembly 4 workbench has been developed by FreeCAD developer named Zolko. Zolko has also created a set of tutorials like this one, for example, the written guides of how to use the workbench. This video tutorial is meant to accompany the written tutorial. Before starting this tutorial, you need to check which version of FreeCAD you're using. If you go to Help, About FreeCAD, you can see I'm using FreeCAD 0.19. This tutorial will only work with FreeCAD 0.19 and later. So once we've confirmed we're using the correct version of FreeCAD, we then need to install the workbench. So to do that, I'm going to go to Tools, Add-on Manager. I'm going to select Assembly 4, choose Install. Okay, once that's installed, we'll need to restart FreeCAD. And select OK. With the workbench now installed, we can select the Assembly 4 workbench from the workbench selector. Following the tutorial, we'll now go ahead and create 3 files to use as the assembly. So we create a new assembly in each file, and we'll save the file. I'm going to save these to Documents, Tutorial, and I've made a new assembly folder to keep all the files together. The first one's the parent assembly file where the other components will be grouped together. So we're going to save, then we'll create a second file, create an assembly model, we'll save. This one will be called Axis, and then create a third file for the imported bearing. So for these files to be used in an assembly model, the path to the files is required. And for that we need to close all 3 files and then reopen them again. So I'm going to go ahead and close the 3 files that we've created and then open them again. So with the files created, closed and then reopened, we're now going to go ahead and model the axis. So I'm going to select the file, choose the model in the hierarchy and add a body to the model. I'm going to expand the hierarchy, choose the body, right click and toggle active body. You'll notice that's now switched us to the part design workbench where we're going to create a sketch on the XY plane. For this sketch I'm going to use the polyline tool. I'm going to produce the sketch shown in the tutorial. So with the polyline drawn, I'm just going to select these 2 ends and add a vertical constraint, then add the dimensions as shown in the tutorial. I'm then going to constrain these 2 edges with a horizontal constraint and then make these 3 edges all the same size. And then final step, I'm going to add a constraint that we'll use later. The dimension of this doesn't matter too much at the moment. If we just call it 25mm, then we'll come back later and have another look at that dimension. So with that done, we can see that the sketch is fully constrained. I'm going to click Close. and save. I'm then going to convert this sketch to a solid using the revolution. Select the horizontal sketch axis and click OK, and then save again. The Assembly 4 Workbench uses coordinate systems to constrain and control the relationship between parts. So the next step is to add some local coordinate elements to the axis part. So to do that, I'm going to switch back to the Assembly 4 Workbench, choose the Model tab, and then select the model in the hierarchy. Going to select New Coordinate System, accept the default name. So you can see we've already got one LCS element at the origin of the part, and we're now going to add a second on this edge. With the edge selected, we're going to choose concentric attachment mode, click apply, then OK. With that done, I'm going to save. And we'll now turn our attention to the bearing component. So I'm going to select the bearing file. I've already downloaded the bearing step file from the Github tutorial. So I'm going to choose File, Import, choose my download, select the bearing and open. Then with that done, we'll select all the elements of the bearing in the hierarchy holding Shift, and then we'll drag that into the model. The next step is then to add local coordinate elements to the bearing. So it's the same process as before. We'll select the model element, choose New Local Coordinate System, accept the default name. I'm going to choose the outer edge, select a concentric attachment mode, apply and OK. Then I'm going to do just the same thing for the opposite side. Select the model element, choose New Coordinate System, accept the default name, choose the edge, concentric attachment, apply and OK. Switch to an isometric view, will fit, and save. With the axis and bearing components now created, we can start to build the assembly. So I'm going to select the assembly file, and I'm going to import part from an open document, select the axis model, and then we can choose a name. As we're only using one axis component here, we can just leave this as the default axis name. I'm going to choose Insert Part. I'm going to select the part to attach to. In this case, it's the parent assembly. And then I'll select the LCS origin in the part and the LCS origin in the parent. Choose Show and click OK to accept. We'll now save the file. So it's asking us if we want to save all the associated files. We'll go ahead and click Yes. And then we can import the bearing using the same method. So import part, we'll select bearing. In this case, we're going to add multiple bearings. So we'll give them unique names. And then we'll select the parent of the axis, select the LCS in the part and the LCS in the parent, and click Show. So that's not quite right. So at this point we can rotate. So if we rotate it around the y-axis, that's now aligned as expected, and we can click OK to accept. Again, we'll add the second bearing, import part, choose the bearing, give it a unique name, insert, and then we can select what we're going to attach to. So we'll attach the second bearing to the first bearing, and we'll select LCS1 in the bearing and LCS2 in the parent bearing. Click Show. That's now aligned as expected. And we'll click OK to accept. So at this point I'm just going to save. And then we'll go ahead and add the final bearing. So we'll import part, bearing, unique name, insert. We want to attach this one to the axis. We'll select LCS1 from the bearing, LCS1 from the shaft. We'll choose Show. So that's not quite right, so I'll rotate around Y and rotate around Y a second time, and that's now aligned. So we'll click OK to accept. Zolko's written tutorial explains that this is an example of a lead screw that you'd find in a CNC machine or similar, with the bearings 1 and 2 providing thrust along the x-axis and bearing 3 being used to just constrain that end of the shaft. In which case you wouldn't want bearing 3 touching this face of the axis, as you would want to allow for thermal expansion, basically the axis to grow. So to account for that, we're going to add a offset to the bearing. So we're going to select the bearing in the hierarchy, then we'll expand the attachment section and the position, and then we'll add 2 millimeters to the Z direction. And you can now see that it's given us clearance between the bearing and the shaft. So with that done, I'm going to save. So as a quick check of the model and to show the power of parametric assemblies, we're now going to change the original sketch that we used to create the axis. So we're going to select the axis file, we'll expand the revolution, right click on the sketch, choose Edit Sketch, and we'll change this 25 to 75, click Close. We can see the axis has changed length. So if we switch to the assembly file, we can see that the axis has changed in the assembly. The bearing has remained in its original position. So we'll click Recompute, and then we can see the bearing's retained its relationship to the axis. So with that done, we'll switch to the isometric view and save. And there we have a brief introduction into the assembly for Workbench. So all credit for this tutorial goes to Zolko. The work that he's doing with the Workbench is absolutely superb, and massive credit to him for making the tutorials to help people learn how to use the Workbench. You'll find links to the forum and the GitHub tutorial below. If you've enjoyed this video, give it a thumbs up. If there's anything you'd like to see in future videos, drop a comment below. Thanks for watching.